All right, so I'm going to invite Dr. Matt Holver back to the podium, Vice President for Research at ASU, to introduce our keynote speaker.
This has been great, being able to spend the afternoon kind of hearing about the things that I've been working in myself for the last 20 years. So thank you for that. I never thought 5 years ago I'd find myself spending my days understanding semiconductor manufacturing and emerging technologies in carbon capture, et cetera. So it's great to be here. And one thing I noticed on a slide, and I might pronounce Min, June. Did I see on your slide you have an R01 starting in April 2020?
Yay!
Congratulations. So congratulations. Well, it's my pleasure to introduce Dr. Elizabeth Parks joining us today. Thank you for making the trip. Very quickly, Elizabeth is a professor of nutrition and exercise physiology at Mizzou. Also an appointment in gastroenterology and hepatology in the School of Medicine, I believe. Fellow of American Heart Association, fellow of American Obesity, not American Obesity, the Obesity Society. Recently president, currently past president, so she's enduring that 3-year charge of her duties there. So much work in the service of our field. Impressive funding record. She's had nonstop funding since 1999. NIH, American Heart Association, American Diabetes Association. Has spent her career studying really the impact of nutrients on fatty liver disease, but health in general. So great career. But the one thing I wanted to point out that stuck out to me as I was looking at her CV, she, I guess, first faculty position in 1999. She's trained 20 early career scientists in that time. 42 undergraduate students, medical students, et cetera, 18 postdocs. So I think her commitment to training the future leaders, the future thought leaders in our field really stuck out to me, and it's commendable. But Elizabeth, thank you for joining us, and I will turn it over to you.
Pleasure.
We'll see. Thank you so much. And I can feel the passion for research and impact in the room. And we are very lucky to be able to participate in this kind of activity every day. I feel very lucky to be involved in research that can have that kind of impact. I find it very difficult to follow your talk. I'm going to try to summarize, again, you're going to see bits and pieces of everybody's talk. I'm not going to speak very long, but I do want to show you the effect of diet and exercise on fatty liver disease because it surprises many, many people. There is an epidemic of fatty liver disease in this country and worldwide. It particularly affects Hispanic communities, and we are now starting to have maybe one medication for this disease when we know diet and exercise can make it go away and make the disease go away. So that's what I want to leave you with today. I think it's important for transparency, and I consult for these companies, and none of what I'm going to talk about today will have to do with that drug development or food development. I want to start with a quote, and anybody who's heard me speak before, this is my favorite one of all science. It is not accidental that all phenomena of human life are dominated by the search for daily bread. Precise knowledge of what happens to food entering the organism must be the subject of something called ideal physiology, the physiology of the future. And that was spoken by Nobel laureate in 1904. And here we are still trying to understand what is the best diet, how to sleep well, how to exercise well to achieve health. What our lab does is we focus on transitions from the fasting state to the feeding state to fasting again. And the basis of much disease happens when endogenous substrates are released during the fasting state. And then when we eat, food coming in competes with what's already in the blood. So it's at that transition that we can uncover disease. In medicine, as you know, most of the measurements that are made reflect the fasting state. I have a physical exam every year. My doctor, she makes me go have my blood drawn, and she looks at my fasting level of glucose to measure my diabetes risk and my fasting cholesterol level to measure my heart disease risk. That fasting level is actually not steady state. That's not a steady state. Richard Feynman said a system is in equilibrium when all the fast things have happened, but the slow things haven't happened yet. In other words, if you fast for a day, you'll have a low blood glucose. If you fast for another day, your ketone levels start to rise. So even in the fasting state, where our body is adapting to not eating. My motto is disease happens when we're fed. If we pulled 100 people off the street, no matter the age, whether or not they have diabetes or not, and we fasted them all for a day, their blood glucose levels would come down to a really tight level. We are not that different when we don't eat. Our body is designed to deal with not having food. It is when we eat that all of a sudden we look different. And that's why the oral glucose tolerance test and the meal test that Dr. Wotruba was talking about are really important because they uncover disease that wouldn't normally be obvious. So these are transitions from fasting to feeding. And a person's analysis of the complexity of the world around us should come naturally, but somehow in biology, modeling of systems has not been universally accepted. We still measure the fasting state. Rather, the culture continues to focus on breaking down systems to the smallest unit so we can study it well. And I think what we've seen today is this transition to understanding dietary patterns, to understanding the effects of sleep, for instance. We see the weather every night, and that weather map on TV comes from AI, machine learning, satellites, all kinds of data coordination. And we're not afraid of that. We believe it. If there's a storm coming, we say, oh, it's coming. Well, that same kind of turning is happening in the body, and we need to start to understand how things are changing, not how they're stasis. So we model those transitions in macronutrients, that's glucose, fat, and protein metabolism, as we seek to study treatments that will reduce disease burden. And I'm going to just show you a couple of examples of that. I'm going to start first by going back to some of the things Dorothy talked about in timing. This is a study from 1975. It probably could not be done again. What they did was they fed people one meal a day for 2 weeks. And they fed them, there were very few people here, and this was a study run by the military, looking at tolerance to a single meal a day. And they did the study twice. People came in, they ate one meal a day, and it was only breakfast. And the next day, breakfast. They could have as much as they wanted. And then a month later, they came back and they could only have dinner, right? And this is body weight reduction there. And you can see that if you only eat breakfast, the body does not accommodate that very well, and multiple people started to lose weight. Also, look at the variance. So that's the precision part of what we're talking about today, is the same treatment doesn't affect everybody the same way. So I was kind of thought, okay, if I can only have one meal a day, I can't shove in enough food to be able to keep my body weight. So people start to lose weight. When I saw this, I could not believe it. So this is that timing that Dorothy was talking about. There are two people here who are extremely sensitive to eating at night. They only had one meal a day, and yet they gained weight. I want to show you another example. This study has been done a couple of different times. This is an older version of it, but it's just great. Georgia State University, they took food records collected from 375 males and 492 females. These are food diaries, and we know they have limitations, but you can capture the kinds of foods people are eating. And the average age, this is a college campus, was 36. These were BMI of about 70, 150 pounds, BMI of 24. So this wasn't a group with a lot of excess weight. So what De Castro did was he analyzed not just what they were eating, but when they were eating. And these data are still a good reflection of the way we eat right now. And that's what I wanted you to see. So on the y-axis here is the mean intake of food. And then he broke up these times of the day into these various phases. And so this is the consumption of carbohydrates, and it's at the top. Everything else is going to be less than that because most of our calories come from carbohydrate. And you see it's kind of flat, but we all know we eat big dinners in America, right? So carbohydrate intake goes up at dinner. There's fat, and still in this country, breakfast tends to be carbohydrate rich, fat and protein low. And so breakfast there between 6 and 10 a.m. was one fat. Here's protein. We tend to put all our protein at dinner. And then because it's a college campus, he looked at alcohol and he could tell that the majority of alcohol consumed. So then he looked at these patterns of the day of eating. And on the y-axis here is the correlation between when people ate and how many calories they ate. All right, and what you're seeing, and these are females in the filled bars there and open as men, that it didn't matter. I mean, men and women were similar. And on that right bar, that set of bars means that the people that ate the most calories at nighttime ate the most calories, period. So if you tended to eat at night in this study, you were eating a lot of total calories. People who ate the most calories in the morning ate fewer calories all day long. So these are the patterns that weight loss programs that we run are trying to, we take information from these basic science studies and we're trying to utilize it to help people. So to help people shift some of their calories from dinner to breakfast. And one of the challenges we have is people add food at breakfast. No. I want you to steal some of the calories from dinner and move them to breakfast. Don't increase your food intake. These correlations were highly significant, and they were the same pattern for both genders. Weekdays and weekends were exactly the same, with and without removing people who they thought weren't very honest, didn't report much, and with and without drinks. All right, so I want to show you. So we've using some of that kind of data. I want to just talk about metabolic transitions and a brief slide of some of the things that we've done. And the example topic I'm going to use is sugars being made into fat in the body. And this is a process, a biochemical, nerdy process called de novo lipogenesis. And that is de novo because that means new. Lipo is fat, and Genesis, like the book of Genesis, things began. So de novo lipogenesis, or DNL, is if I eat a sugar, I will find fat in my body that came in as a sugar. It's not butter on the plate and butter on me. It's jelly beans made into fat in the body. Okay, that's what we're talking about. And when I started my career, everybody said this was not an important topic, doesn't happen in humans. We'll see. So the first thing we did was we defined the natural sugar stimulation of de novo lipogenesis in healthy people. And I'm talking about these data because I want to show you what happens at that transition from being fasted and then eating sugars. And we had some publications in here. Then we went to the effects of drinking alcohol and eating. And I'm going to show you a little bit of those data. That's called the tailgate study. Then we discovered that this pathway was high in something called non-alcoholic steatohepatitis. It's a disease that's NASH that's now been renamed. So I'm going to use the old terms for today. And this paper, we took people who were already sick with fatty liver disease and we traced fat synthesis. And then lastly, we investigated this disease and fat synthesis in the liver. And I'm going to show you circadian rhythms. Okay, so this is de novo lipogenesis. That's the liver, sits right here under your rib. Glucose and fructose come in through magic of biochemistry. You make a fat. It's called a triglyceride. And sometimes that fat gets stuck in the liver. That's those little yellow droplets, or it can come out into the blood. And we can see evidence of what's going on in the liver by drawing blood and looking in this little cholesterol particle here on the right. All right, so this is the first study that we did in healthy subjects, and we did this study twice. We've heard about stable isotopes a couple of times today. In this case, we bought that stable isotope from the stable isotope store. It's clean, it's sterile, and we infused it into people. And when people are making fat, that little molecule gets incorporated. So we can watch it actually happen real time in the human body. So we did the study continuously fed. And then these guys, so 12 guys did the continuously fed study. That means I put a feeding tube down past their stomach into their duodenum and turned on a chocolate shake, basically. And I wanted to feed their body sugars just really steady. And I wanted to do that for 9 hours. And they were very nice and they tolerated it. And when I said, would you come back and now drink that same solution fast in a breakfast shake and a lunch shake, 6 guys or 8 guys agreed to do that. So we're measuring, these are little blood draws coming out of an IV line. We're measuring metabolism in the fasting state and the fed state. And we're going to start with the continuously fed state. And we are actually drawing blood. We sneak into the room while they're sleeping. The nurse has her little flashlight in her mouth. She takes a little blood out and goes out. And they're not sleeping really well, but they're waking up. Oh, there's the nurse, and they go back to sleep. And about the 3rd or 4th time this happens in the night, they get used to it and they sleep through. So we were taking information in the night, and then we turned on the feeding tube, just like you would in a hospital. I'm sorry, but I made these data come up really slow because I just wanted to enjoy it. It was such a hard study and being up all night and everything. So I'm just honoring the fact that there are people in this room that look at this and go, oh my God, I can't believe you tried that. So what's happening? That's fat synthesis there on the left-hand side. We're making body fat from sugar at 1 o'clock in the morning while we're sleeping. So what you heard earlier today is that you eat to store. And all day long, you're better and better and better at storing. And in the middle of the night, the sugars that we eat at 10 o'clock when I'm watching the news, that's when fat can be made from sugars. And in this subject, as he was becoming more and more fasted, his body was basically saying, don't waste sugar anymore making fat. You're not eating. We got to save that sugar. And so lipogenesis is dropping. Then we turned on the formula, which had sugars in it, and went up. Okay, now I'm going to show you everybody, and this is the precision part of this. Look how different they are. And when I saw this, I thought, oh no, I can't study this pathway because we don't even know why people are different. Look at this pink guy over here. Look how fast he suppresses this pathway. His body knows he's fasting, and it immediately turns this off. And then when we fed him, it pops right up. See a pink, that little pink square? The poor person, the guy at the top, making lots of fat. And the minute we turned on the feeding tube, it started again. And so this was so early in this field of science. I thought, okay, are they different by age? Nope. Age does not predict this at all. Are they different by body fat? No, that doesn't either. And I will not forget that 23-year-old pink guy, because he had 7% body fat. He was a collegiately ranked soccer referee. And you know what it's like to be a soccer referee. You're running. He was like a coyote. This guy, his metabolism was so tuned up. And then you've got this person down here, same age, 7% body fat. And look what happens. He doesn't make any fat from sugar. Hardly any effect at all. So this is the propensity for fat synthesis that we need to begin to understand, because dietary advice should be slightly different for each of these people. All right, now I want to show you when you drink it instead of when it's given to you slowly. So this is subject number 1, fasting, fat synthesis there on the left, and then we fed him 2 meals and just immediately like a rocket. His body senses he's eaten, and let's make fat. And here is everybody else. Again, a very big difference. Big peaks there in subject number 4. And then there's insulin. So insulin is turning on this pathway, sensing the glucose and turning it on. So now we've got this method figured out for science. Now we have a tool. And now we can compare these 2 states. Here's the average, which you know there isn't any one person that looks like that average curve. We see this all the time in my field. Here's the average glucose. Nobody looks like that. That's an average of 1 million different responses. And there's the meal. And so our subsequent work has shown that if it's liquid sugar, if it comes in faster, it will make more fat. So complex carbohydrates from rice, from various complex peas, corn, beans, all of those will come in much, much slower into the body and produce the bottom pathway. Kool-Aid, Coca-Cola, right? Coming in sugar, you're just dumping sugars into the body. All right, now we're going to turn to the tailgate study. And of all the studies we've done, this is the one that gets the most attention. This is that complicated protocol that you've already kind of seen these. Time is always left to right. These people came in, had a liver scan that didn't hurt anything, put them in the scanner and in the fasting state. And then we gave them a treatment, and then they were inebriated. So they had to stay in the clinical research center overnight and dry out. And then the next morning we drew blood and they were discharged, and they had a second liver scan. So what was the treatment? This is, this looks like a tailgate. We had a buffet. They were able to eat as much as they wanted. And we kept refreshing, the dietitians in the audience know, we kept refreshing the buffet. So now here's the chicken wings, and now here are some cupcakes. And so novelty will increase food intake. As two guys did this study at one time, watching sports on TV. It was a pretty happy study to be around. 3 days before, we fed the subjects heavy water, just like you've heard earlier. Again, heavy water, it tastes like water, looks like water, it's relatively cheap. And when someone takes that and I draw their blood, I can see new fats there. All right, it was 18 overweight subjects studied only once, and here is their subjective intoxication on the left-hand axis there. A 0 would be I'm not drunk at all, and a 10 would be more drunk than I've ever been in my life. And we got these guys up to about a 4 or 5. Again, not sloppy, but happy drunk. And I made sure we stayed around the legal limit of Missouri. So we brought them up and kind of clamped them to this breath alcohol level. All right, and this is to remind me that they had a liver scan before and at the end of the treatment. And I went to the grad student and I said, go plot that data for me. This is a lot of calories. This is alcohol. I'm pretty sure we're going to produce acute fat in the liver. I thought for sure that is what would happen. And it did not. And I said, you've made an error. He said, no, I didn't. I said, go back and look at the data again. And he brought me this slide. So there are subjects, this is each subject who got in the liver scan. There are subjects whose liver fat increased significantly and some whose liver fat actually went down by overeating in the afternoon. And so then I said, okay, divide them up. So we arbitrarily drew a line and averaged the two sides. On the left-hand side is what they ate for those people whose liver fat increased. On the right-hand side is what they ate if their liver fat decreased. They did consume 5,000 calories of food, and alcohol was 20 to 32% of the calories they consumed. What's interesting is that the people whose liver fat went up, their sugars were slightly higher. Their alcohol intake was slightly lower. And these were people who imbibed normally. We didn't take people with really high habitual alcohol intake or teetotalers. We got that middle tailgating group. So we measured lipogenesis, and this is what it looks like. The fatty liver, the people whose liver fat went up had the stimulation of this pathway. And when we compared the liver scan to the isotope, which is a definitive measurement, we found a significant correlation between the two. So this isn't to say that excess alcohol in food is good. It's just to make the point that we can't tell by the average thing we read in the headline in the newspaper. And that when I'm talking with patients about what will help them with weight loss, I'm mindful that the standard advice that we started this whole afternoon with may not be good for that person sitting in front of me. We need to be really careful. All right, so this is lipogenesis in the fed state in healthy subjects. And at the same time, we were studying patients with NASH, and look at it. There's no change. It's just high and it stays high, whether they eat a meal or don't. All right, so I'm just going to show you some studies of circadian rhythm. Does de novo lipogenesis matter to liver disease? The effects of diet and high intensity interval training. This is HIIT training. We've just finished this project. We're going to start with this. So Majid Saeed in my lab partnered up with the bariatric surgeons, and he sent labeled water through the mail to people in southern Missouri who are heading to have bariatric surgery 2 weeks' time. So this is one way we can engage. Sometimes research studies at universities always study students, faculty, staff. And what's really nice with isotopes is that you can send them out, have people drink this water every day, and then just show up for their surgery. And so he knew he could do this, so he would send them a FedEx the box, and then he'd get on Zoom and tell them, look, it's just water, let's drink it together. And they could, all their questions could be answered. They were not going to glow. It's kind of a boring experiment. So this is getting excess waste liver tissue from someone undergoing bariatric surgery, and he's analyzing the kinds of fats in the liver. And here is gene expression. So now he's analyzing protein activity, and it correlates with the isotope measurement. And then lastly, important for me, when he measured fat synthesis in the liver directly, it correlated really well with the plasma marker. That means we don't have to have liver tissue. We can just draw blood in an average experiment, and we can really tell what's going on in the liver. Okay. Those liver samples underwent histology, and on the left-hand side is the level of fat synthesis in people with a completely healthy liver. Now, I'm going to remind you that these were patients going to bariatric surgery. There was one woman in this study who weighed 350 pounds. She was 150 pounds fat on her body, and she had no fat in her liver, 0. Again, we can't assume if somebody has excess weight that they're unhealthy. In this aspect, these subjects on the left-hand side are just fine. As you go left to right, you get worse and worse disease that we can see under the microscope, and lipogenesis is elevated. And then what Majid did was he divided the samples up. Steatosis is fat, inflammation, ballooning is a sign of dead liver cells, and fibrosis is scarring. And as he looked at the people who fell into these various categories, he found that the pathway of fat synthesis in liver kept rising as people got sicker. And when they got very sick, then the liver is failing, and now lipogenesis is down. So why do we care about this? The reason we care about this is I started telling the American Diabetes Association and the American Society for the Study of Liver Disease that maybe in your dietary guidelines, you should say that cutting simple sugars is not a bad idea. And that finally changed. I can say it, and our studies are cited. 4 years ago, the American Diabetes Association finally changed its dietary guidelines. All right, so let's look at the effect of a diet. So these are patients with low liver fat. They're insulin resistant still, but they don't have a lot of liver fat. And I'm measuring fat synthesis at midnight, that's time 0, all night long, and then we're feeding them a lunch. And these are patients with high liver fat and disease, liver disease. The pathway is elevated. It doesn't really suppress with fasting. So we took these folks and we put them in a 6-month weight loss program. And here they are, all losing weight. And you can see this is weight loss on the y-axis. And the bars are pretty narrow. Everybody in this study lost at least 8 to 12% of their, 8 to 10% of their body weight. And that's the liver fat, again, by a scan, a liver scan. So we've got people with low liver fat, and they even came down a little bit. Their liver fat dropped in the black there. But look at how fast you can plummet liver fat with weight loss. So there was a weight loss effect on fatty liver. So these people are in the hospital one by one with an IV, and this is their blood glucose concentrations. First, after dinner, And before weight loss is the open circle, after weight loss is the filled. You can see glucose going up in the blood and coming back down. And now at nighttime, they're sleeping and their blood glucose is steady. And then I wanted to see how well they fasted. So I made them miss breakfast and made them wait for lunch. So right about 12 o'clock the next day, we fed them another meal. And the point I want to make from this picture is I said that feeding uncovers the differences between us. Look how narrow, I don't know that this will work, how narrow the variances are, that the error bars at midnight. They're really, everybody's the same at midnight. And then when you feed people, all of a sudden you got a dot and a line above it. It's much bigger. That's because we're all very different after the meal. And you can see this all in the literature if you look at it. So there is the people with high liver fat. There were no diabetics in this study. So everybody's glucose was pretty much the same. There's their insulin values. Look how much weight loss reduces insulin. And then this is the lipogenesis data. If you have low liver fat and you lose weight, this pathway is just suppressed, just comes right down and stays low. Whereas the people with fatty liver disease didn't suppress that much. And we also they didn't gain a circadian rhythm. They're just put, slowly suppressing the pathway all night long. Right? So they did suppress lipogenesis, but there's something about this group on the right that makes liver fat storage and liver disease, they're more at risk for that, even when they lose weight. I'm almost done here. I'm just going to show you the results from a 5-year slog of a study where we put people through 9 months of diet and high intensity interval training. For those of you who don't like science, you can just ignore this, but this is what we did. That left to right, that's 9 months. We had a standard of care group on the left-hand side and a treatment group. High intensity interval training HIIT, many of you know about that. We did exercise treadmill tests, liver scans, insulin clamps, DEXAs. And then at the end, we repeated everything. And the patients underwent a follow-up liver biopsy. And you'll say, that's invasive. They knew exactly what a liver biopsy was, way more than I did, because they had one for their medical diagnosis 9 months earlier. When I asked subjects, when I asked them to be in the study, I said, you just had a liver biopsy. Would you go through another one? Oh, yeah. I said, well, so you don't want to be in the study? No, why? I don't want the diet. They would exercise, but they did not want to change their diet. So the people that didn't enter the study, it was because of the diet, most of all. And they knew they were going to have a coach on the treadmill, and we were going to try to make that exercise easy. But if you show up to exercise 3 times a week, you're done. Check the box. Whereas dietary challenge is every day, 3 times a day. You're really trying to control a behavior that's constant. So dietary changes, I think, are much more difficult. So here's who they are. There were 8 subjects in the standard of care and 16 subjects in the treatment. And the standard of care and the treatment were all people with liver disease. And so they knew they were sick. And so our standard of care was their doctor's standard of care. But you will see some of these people lost weight. They were scared. They'd just been told they had terrible liver disease. So this is really ecological, I think, in terms of the way the study was run. Their VO2 max is really low. They were sedentary individuals. All right, so there's the weight loss run by Jennifer Anderson. That's the control group. You can see some people stayed the same. Some people lost weight on their own, all by themselves. And there is the treatment group. We've got some people losing a lot of weight and some people who are showing up to all the exercise bouts and everything, and they're not losing any weight at all. Some went off their diabetes medications, as you can imagine. All right, so this is changes in liver disease, and these are what the liver looks like through a microscope. And the histologist, the pathologist has graded these. When you look at liver disease, a 0 is healthy and an 8 is very sick. So that's called the non-alcoholic fatty liver or NASH activity score. The person, subject number 1 there, had a 7 at the beginning, And what you're seeing, those little dots, that's fat in the liver, stored in the liver, that the pathologist can see inflammation in there as well. And at follow-up, the follow-up liver biopsy, this patient didn't have any improvements in liver. Subject number 2 went from a NASH score of 6 to a little bit better to a NASH score of 5. This is an example of 2 patients in the treatment group, went from a NASH score of 7, that's a really bad looking liver if you're a pathologist, to a NASH score of 2. This, the pathologist is blinded. They don't know if it's a baseline study or a follow-up study. And this pathologist sent me an email that said, you send me the wrong slides. And I said, just put a score on it. And he said, but this can't be your study. And I said, please just score it. He said, but this looks like a liver sample from a healthy college athlete. Beautiful pink. You can see the nucleus in the cells. So that's what a healthy liver looks like. And this person did this for themselves with diet and exercise. On the bottom, there's another subject, came a really long way. She went from a 6 to a 2. All right, so I'm going to show you those liver histology scores because I think, to my knowledge, we're the only ones in the country with any data like this. So that there's a total NAS score, which is 8, and that's the standard of care. And you can see some people got worse, some people got a little better. Here are the NASH scores improving in the treatment group. 1 guy got worse, 3 didn't change, but some people just completely improved their liver. And that score is made up of steatosis, which got better in treatment, that's fat, inflammation down significantly, and cellular death down significantly, along with fibrosis tending to improve. I think scarring takes a long time to improve in patients. So here are the physiologic mechanisms for you physiologists. The more weight people lost, the more their lipogenesis came down. Less fat synthesis in the liver. The more their fat synthesis dropped, the more the liver scan picked that up. People that got worse, their lipogenesis went up. The more their cardiovascular fitness, the better their liver, the more the liver's getting better. Even if you take that unbelievable woman off, her data off in the lower right-hand corner, this is still correlated. And then lastly, hepatic glucose production. This is what causes diabetes, is the liver putting glucose out. And that was significantly correlated with liver fat. So their glucose production improved. So we tried to analyze, is it the sugar in the diet? Is the lipogenesis? What is it? And this pathway, this biochemical pathway, and we're going to go into this, it really outstrips the effect of sugars even. So if this pathway is high in the body, fatty liver will be high. So this is what we call the reroute hypothesis. We're going to reduce food intake, primarily through the reduction of sugars, and that's going to reduce body weight. And at the same time, we put them on the treadmill 3 times a week, and they increase their physical activity. For the molecular biologists in the room, those are the genes that would be affected. And we're putting less food into the body. We're taking the stress off the liver, right? Overnutrition is what many of these patients struggle with. We just take that away and their body will heal. Fitness increases the burning of substrates in the muscle. So we're denying them some food, and the food we give them, it's not going to their liver, it's going to their muscle because they're on the treadmill. And so this is what we saw: reduced liver fat and cell death, lower glucose production, and we found remission of diabetes, prediabetes, and fatty liver disease. So in summary, eating late at night allows calories to come in at a time when the body is primed for fat storage. Different people vary in how they store calories. Sugars in liquid form are more lipogenic, and that they 5 times more lipogenic than solid food. Lipogenesis is the distinctive characteristic that increases fatty liver disease. And we've now done this for 25 years. Age doesn't probably matter. Diabetes certainly does matter. And when someone has diabetes and liver disease, this fat synthesis level is up. It's the one thing, men and women, different genotypes, it's the one thing that predicts the disease. And lastly, weight loss and exercise that caused resolution of liver disease affected metabolism after meals, particularly after dinner. So I applaud your strategy to reduce food intake at night. My lab has a motto, it's Pantere, which is Greek for all things are in flux, and my students always want me to tell you that. We appreciate all the volunteers. We don't learn anything if somebody doesn't raise their hand to be in a study. That's the funding. Here are the grad students and fellows, and the undergraduates who last fall we had a new undergraduate working in the lab, and after about a month, she came into my office, she put her hands on the door, and she said, "Are we going to win the Nobel Prize?" And I said, no concern. But to your point, we're training students to understand that we were doing diabetes research. She got kind of the general text of what we're working on. And that has a huge effect to train the next generation. My staff, and then I work with some amazing scientists. Before I went to Missouri, I'm still collaborating with lots of other investigators. So I will stop there and thank you very much.
We have time for a few questions before we transition to the larger Q&A session.
Yeah.
Fantastic work. So interesting. So I'm thinking about insulin. I like to think about insulin a lot. So with the carbohydrates and, insulin is a major driver of de novo lipogenesis in the liver. So eating the carbs is going to drive that. Eating a simple carbohydrate like your liquid meal is going to drive an insulin spike, as you showed. So I'm wondering, in your correlations that you showed kind of in the later data, did you look at a correlation of how the fasting insulin levels with
Yeah, so we compared
liver?
insulin, we compared sugars in the diet or carbohydrate in the diet, and then lipogenesis to predict fatty liver disease. And fructose doesn't raise insulin very much, and fructose is almost more lipogenic than glucose is, for reasons you understand, right? It just slides right into metabolism to make fat. So insulin's really important. And we know that when you lose weight, insulin comes down much more than glucose. You'll see glucose come down, but really the major effects of weight loss are to get the insulin down. And we have lots of patients who are waiting for us to measure their insulin in the lab and let them know their hemoglobin A1C too, so that they can find out how they're doing.
But did you see the correlation with the insulin and the fatty liver?
Not the question is, does insulin correlate with fatty liver? Somewhat, but not as strong as lipogenesis does.
Gotcha.
Yep.
Thank you. Thank you.
Yeah.
All right, thank you very much. That's a lot of work, many years of work right there. I think it was the study with the bariatric surgery patients and the NASH. And on the average, the de novo lipogenesis was higher. But there were some people at the bottom, I was looking at individual data points, that fatty acid, de novo lipogenesis was even lower than the healthy people. So I was wondering what's going on there.
In the bariatric surgery group, there are people who have, who, as I mentioned, they have fat on their body, but not in the liver. They are protected in some way. Yeah. Yep. If I understood that, then I could really make it. Yeah, that's the precision part of this. Why do some people put fat out here and not in here? If you think about it, if I'm gaining weight and I'm able to expand my body fat, I'm protecting my other organs. So it's not such a bad thing. And then we'll go back.
All right. Yeah. So first off, phenomenal talk. Just really exciting, all the work you've done. Can you say something about the timing of exercise and lipogenesis? Have you observed anything there?
We haven't measured the effect of exercise on lipogenesis. The metabolomics, when you look at markers in the blood, they tend to be lower afterwards because you're basically taking sugars that would make fat over here and you're putting them over there. There's a big controversy of whether you should exercise at night or exercise in the morning, blah, blah, blah. One of the studies that showed that exercise in the morning is better is simply adherence. It's better because people will do it, get it out of the way and go to work. Whereas if you're like me, the day just keeps going. And if you're going to exercise at night, that can get usurped by grant review or whatever you're doing at 10 o'clock. So people, really, to be as adherent at night is tough, especially when you got to feed kids and everything else. So yeah, exercise in the morning.
Great presentation, thank you. I have a question. Have you had the chance to look at different types of lipids in the liver, like ceramides, monoglycerides, diglycerides? There has been a lot of work in the muscle tissue.
Mm-hmm. I'm currently working on ceramides, and we've compared cholesterol esters and triglycerides, and they do go up together. And that you see that in every mouse study that was ever published. If triglycerides go up, cholesterol ester also goes up. And phospholipids there are markers of phospholipids that are really good markers of fatty liver. But that's, for this.